In these problems, we're going to try to find what's called a limit by using a graph. And a limit is kind of an odd concept, at least when you first come across it. Basically, what a limit is saying is, on a function, if I get the input of the function as close as I want to some value, what is the output tending toward? What is the output getting close to? And it's important because look at this function right here. It's a piecewise defined function. The function is 4 minus x, which is this line here, for every number except x equals negative 6. At x equals negative 6, suddenly the function's value is negative 5. So if I were to ask what is the value of this function at x equals negative 6, you'd say negative 5, and it wouldn't give me any information about the whole rest of this function. But if I asked you what is the limit of this function as x approaches negative 6, what you'd want to do is get closer and closer to the value from this side, closer and closer to that value from this side, and the answer would be whatever value you are tending towards. And you can see you're tending towards that empty spot, but because we never quite get there, we can say that the limit of this function at x equals negative 6 is actually 10, because that's what we're getting closer and closer to from both sides. So the answer to that one is 10. Let's look at this next one. Here you can see limits are interesting and tell us something about what's going on with a function. Sometimes the limits don't exist. What is the limit of this function as x approaches negative 2? So here's negative 2, and on top here it looks like it's getting closer and closer to infinity, positive infinity, as it gets closer and closer to negative 2. On the bottom, it's getting closer and closer to negative infinity as it gets closer to negative 2. Because there are two different values that this function is approaching as it approaches negative 2, we would say this limit does not exist, and sometimes we just write that as DNE. All right, let's look at another one. Now here you see this same kind of asymptotic behavior where you got your function split up going in two different directions, but be careful about this one. This says what's the limit as x approaches 4 of 1 over x minus 3. And let's see, 1, 2, 3, 4. So there's where x approaches 4. And if I come at it from this side, it looks like it's approaching 1. If I come at it from this side, it looks like it's approaching 1. I've got the same from both sides, so the limit there is 1. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethischool.org. Thanks.